Welcome back to lesson 3.1. To finish off this lesson, we're just going to go through some more examples of solving quadratic equations. Okay, so first one, x squared equal to 225. X squared is already by itself, so all we need to do is cancel the exponent by square rooting both sides. Square root and square cancel, so we have x by itself, and then 225, we square root it to get 15, and we remember that there's a positive and a negative square root. So we actually have two solutions. It could be positive 15 or negative 15. All right, for number 2, we have to isolate x squared. So we're going to start by getting rid of that plus 4. So we'll subtract 4 from both sides. That will give us x squared equal to 29 minus 4 is 25. Then we can square root both sides to get rid of our exponent. So square root and square cancel, leaving just x. And then we have the square root of 25 is 5, and we could have the positive square root or the negative square root. So our solutions for number 2 are plus or minus 5. Okay. Number 3, we also need to isolate x squared, so get it by itself. So we're going to get rid of plus 16 by subtracting 16 from both sides. So that gives us x squared equal to 10 minus 16 is minus 6. And here we have a red flag going up because x squared can't be equal to a negative number. It has to be positive. So our conclusion here is that this equation has no real solutions because x squared cannot be equal to a negative number. Okay, so those were kind of 3 basic examples. Now we're going to go through 3 that are a little bit more complex. All right, x minus 11 all squared equal to 16. So we'll start by getting rid of that square by square rooting both sides. Square root and square cancel, leaving just x minus 11. And then the square root of 16 could either be positive 4 or negative 4. So now, since x isn't all the way by itself yet, and we have 2 numbers on the right side, we have to split. So either x minus 11 equals the positive 4, or x minus 11 equals the negative 4. Then we'll continue solving each of our cases for x. So add 11, add 11. The first case gives us x equal to 4 plus 11 is 15. And the second case, add 11, gives us x equal to negative 4 plus 11, which is 7. So we have 2 solutions here. X could either be 15 or it could be 7. Both work. All right, next one. Similar idea, but first we need to isolate x squared. So the first thing we need to get rid of is the minus 13. So we can cancel that by adding 13 to both sides. So then we're left with 3 times x plus 2 all squared equal to 14 plus 13, which is 27. Okay, then we need to get rid of the 3. So it's times 3, so we can get rid of it by dividing by 3. That will leave us with x plus 2 all squared equal to 27 over 3 is 9. Now we want to cancel the exponent, so we're going to square root both sides. Square root and square cancel, leaving just x plus 2. And then on the right side we have square root of 9, so that could either be the positive or the negative 3. Okay, so x isn't all the way by itself yet, and we have 2 numbers on the right side, so that means we have to split. So we have 2 cases. Either x plus 2 is equal to the positive 3, or x plus 2 is equal to the negative 3. Then we can solve each case. So I can subtract 2 from both sides. And I can do that over here too. From the first case, we get x equal to 3 minus 2 is 1. And from the second case, we get x equal to negative 3 minus 2 is negative 5. So 1 or negative 5 are both solutions to this equation. All right, that's the most complicated one we've done so far, but again, the process is isolate whatever is squared, square root both sides, remember plus or minus, and then split into cases if needed. Okay, last one. So we're going to start by isolating whatever is squared. That looks kind of complicated, but we're going to deal with it later. We're just going to isolate it first, so we need to get rid of the 6. So we're going to do that by subtracting 6 from both sides. So that leaves 5x plus 20 all squared. And then on the right side, we have 6 minus 6 is 0. All right, our next step is to get rid of that exponent. And we do that by square rooting both sides. So on the left, square root and square cancel, leaving just 5x plus 20. And then on the right, we have square root of 0. And this is the one number that we don't have to worry about plus or minus for, because plus 0 is exactly the same as minus 0. They're both just 0. So square root of 0 is just 0 by itself. So we end up with 5x plus 20 equal to 0. Then we're just going to solve that for x just like normal. So we're going to subtract 20 from both sides. That gives us 5x equal to minus 20. Then divide by 5 to get x by itself. And we end up with x equal to minus 20 over 5 is minus 4. So this equation has only one solution, x equal to minus 4. All right, so that's it for lesson 3.1, solving basic quadratic equations.